So this is called sigma notation. Sigma notation. This symbol here looks like an E, is called sigma. It's a Greek letter. Sometimes we'll call it summation notation. And what this thing does, it looks very intimidating, but it's really not too bad. So all you do is you take this first number and you plug it in. So when I say the first number, I mean the number on the bottom, where it says n equals 1, you plug that in. So we do 13 plus 4 times 1 minus 1. When I do that, I get 13. And then I plug in 2. I'm going to go up to the next number, so it'll be 13 plus 4 times 2 minus 1. When I do that, I get 17. Then I'm going to plug in 3, and I'm going to keep going, so it'll be 4 times 3 minus 1. I get 21. And I'm going to keep doing this. And I'm going to stop. I'll tell you when to stop in just a moment. So 25, 13 plus 4 times 5 minus 1. There's the bell. 29. And then 13 plus 4 times 6 minus 1 is 33. And so where do we stop? We stop there. This tells us where to stop. This tells us where to start. So you don't always start at 1, you don't always end at 6, but in this one you do start at 1 and end at 6. And then once you plug all those in, then you just add these up. So if I add those up, let's see, I get 138. So this would just be 138. So that's it. It's really not that intimidating. It looks a little intimidating, but you're just plugging in the bottom one. So let's look at a couple more here. We're going to plug in 1. So it's going to be negative 15 plus 9 times 0. That's going to be negative 15. Then I'm going to plug in 2. So negative 15 plus 9 would be negative 6. Then I'm going to plug in 3. I'm going to get 3. I'm going to plug in 4. And I'm going to get negative 12. So all I did was for n, I plugged in 1, I plugged in 2, I plugged in 3, I plugged in 4. This told me where to start, and this told me where to stop. And that's where I got these 4 terms from, by putting in 1, 2, 3, and 4. I add these together. Sorry, this is positive 12, not negative 12. So I add these together and I get negative 6. So not too bad. On this one, we're not starting at 1, we're starting at 5. And so it'd be 4 times 5, that's 20, plus 9 is 29. And then I plug in 6. 4 times 6, 24, plus 9 is 33. Plug in 7, and I'm going to stop at 8. So I'm going to keep going here. I'm going to plug in 7, I get 37. Plug in 8, I get 41. And when I add these all together, I get 140. So this was by plugging in 5. This was plugging in 6. That was putting in 7, and that was putting in 8. So um, on something like these two, like we'll skip the third one. We'll do this one. We're gonna start at 4. We'll put 4 in here. So this would be, how can I write them all out here? 7 minus 2 times 4 plus 3 squared. Remember, we do have to do things in order of operations correctly. So 4 plus 3 is 7. So it'd be 7 times 2, or 7 minus 2 times 7 squared. We do not combine the 7 and the 2 to 5. Remember, multiplying and exponents come before adding and subtracting. So 7 squared is 49. It'd be 7 minus 2 times 49. We multiply next. 2 times 49 is 98. And we get 7 minus 98, so this would be negative 91. So that's for the first term. That was just plugging in 4. And then if I put in 5, it would be 7 minus 2 times 5 plus 3 squared. And if I do all that work, I'm just going to cheat a little bit here and use my calculator. I get negative 121. And then I plug in 6. let's see, same thing, that changes to 9. Get negative 155. So then you add those three together, and let's see what we get. We get negative 367. So just plugging in one at a time, just with some of these, you got to be careful with your order of operations. Okay, what if we're going the other way? So can you write it in sigma notation given an arithmetic series? Well, this one looks like it's going up by 2. And the first term is 6. So if I were to write a formula for this, it'd be 6 plus 2 times n minus 1. So that's what we're going to put out here. 6 plus 2 times n minus 1. But the question is, how do we know where to start and how do we know where we're going to stop? Well, it's not too bad. We're going to start at 1 because this is our first term. And then this is our fifth term. So we're going to stop at 5. And that's it. So if it gives you a series, you're going to always start at 1, and then you're going to end at how many terms there are. So in this case, 5. And then you just write our arithmetic sequence formula there. So, yeah, that's pretty much it. We'll do one more here, maybe. This one don't do because there's a typo. So looks like we are going up by 6. For geometric, it would be slightly different, but not too far off. To go from a geometric sequence to the sigma. I mean, really, it's the same method. You figure out your general formula, and then you throw that here, and then you put the number of terms. Anyway, yeah, so it's the same thing with geometric. So this would be negative 12 plus, we're going up by 6, and minus 1. And then we're going to start at 1, and we're going to end at 6 because there are 6 terms. All right, so that's it for sigma notation.